So the very useful way of understanding what all this means is the following. When you look at evolutions and transitions, etc., the smaller you make your state space, typically the fewer states in a partition will be accessible in one time step. It seems pretty obvious. If I have a very sharp initial condition, there'll be few little regions where I can hit because I'm moving deterministically. So this initial condition has to stretch. This region has to stretch and overlap with a bunch of regions. In short time, this is going to be small. So as we partition the state space, you can always see here what happened. First, we had 3 partitions, 0, 1, 2. Then we realized that if you look 2 steps in the future, each one of them can divide in 3 partitions. So suddenly you have 9. If you look 2 steps in the future with 3 to the 3rd power, so the typical number of possible states and dimensionality of this matrix grows exponentially as partition, because this is going to be n times n matrix where n is the number of partitions. That's going to be a very large number. But evolution will be only reaching few of them, which means there will be very sparse matrices. And for sparse matrices, it's very effective to use alternative representation, which is represent them as graphs. I personally find graphs much more efficient and much more intuitive in dealing with dynamics. If you write partition, of course you can write, except in higher dimensions. In plane you can draw it, but if it's 100,000 dimensions, it's a little harder to visualize it. And now these matrices are totally useless, because I can't write them on a piece of paper. Because if I have 7 letters in an alphabet, I'm looking at 7 to 7th power. This is a humongous matrix. But the graph can be incredibly concise statement of what it is. So the idea of the graph is that when we look at this partition, we can abstract from it what's essential. And what is essential is that we can think of this whole region, we can draw it as just a little circle and give it its name, 21. Then this region here we can draw as a little circle again. And this region is another circle. And this region is a 3rd circle. Giving them whatever names you like, 1, 2, or A, B, C, D, or whatever our alphabet is. All I care about is that from this region I can reach these 3 regions in one time step. So this can be thought of as a graph. These are nodes, this 3 thing here and that one there. These are the links. And they're directed links.